Hello. I want to do these three problems at once because they're very similar for one thing. Okay, we're trying to calculate these limits as x approaches infinity. And the sort of the trick to them is always to rewrite the expression so that you can see what's happening. You see, if you look at this expression here, you'll notice that both the numerator and the denominator are going to infinity, so there's a chance this limit exists. So let's rewrite this. What I'm going to do is I'm going to take the expression, and if I multiply both the numerator and the denominator by 1 divided by x squared and use the distributive law, watch what happens. This is equal to, I just get 7 plus 2 over x divided by 9 minus 5 over x plus 1 over x squared. Now notice, I'll just say this, that if I calculate, so if I calculate this limit as x approaches positive infinity, it will be the same as if I calculate this limit as x approaches plus infinity, because we're not going to be near 0. And these expressions are both well-defined away from 0. So, but notice what we get. Here we can see that this part goes to 0, this part goes to 0, this part goes to 0, so we're left with 7/9. Now let's watch what happens here. Notice the key here is that the degree of the numerator, the polynomial of the numerator, is the same as the degree of the polynomial of the denominator. Now in this example, we'll basically use the same sort of trick, and that will just rewrite things. So watch this. If I take 9x cubed plus 6x minus 5, and if I divide that by 4 x to the 4th minus 6x cubed, minus 8. Okay. Now watch, if I divide the numerator and the denominator by 1 over x cubed, I'm choosing 1 over x cubed because then I can see what's happening here. Watch this. I get 9 plus, then I get 6 over x squared minus 5 over x cubed divided by, now here I get 4x, there's still an x because there's an x to the 4th. X to the 4th divided by x cubed is just x. And minus 6 minus 8 divided by x cubed. Now, if I now try to calculate limits as we approach infinity, then I have to do a little cleanup work here. Get rid of this equal sign. Or actually, I'll just move it over a bit. So this would be the same as the limit as x approaches infinity, the thing on the right. And let's see what happens. Well, now look. Look at the numerator. The numerator is getting close to 0. So we have 0 in the numerator, right? I'm sorry, we have 9 in the numerator. Let me clean it up. Haste makes waste. So the numerator is getting close to the number 9. And the denominator is getting close to what? Let's see. So the numerator is getting close to 9 because this is getting close to 0, and this is getting close to 0. But the denominator, since x is approaching positive infinity, this is getting close to positive infinity. Now, this is a horrible abusive notation when I put positive infinity there. That's not something you want to do. But since I can verbalize this, you want to keep that, be mindful of the fact that that's getting close to positive infinity. So as a result, we can see that our limit is going to be approaching 0. essentially the reason this is happening is that if you look at the degree of the numerator, it's 3, right? And the degree of the polynomial in the numerator is 3. And the degree of the polynomial in the denominator is 4. So when you calculate when you look at their quotient, the polynomial in the denominator is getting close to positive infinity. We would say quicker than the polynomial in the numerator. And that's why we get 0 in the limit. Okay, let's take a look at the other situation. Well, in the other situation, just the opposite is happening. This is the next example. We have, when we rewrite this, we get 4x to the 4th minus 6x minus 6 divided by 7x cubed minus 7x minus 6. Now, when I divide the numerator and the denominator by 1 over x cubed, then I get 4x minus 6 over x squared minus 6 over x, what is it? Cubed, right? Divided by, now here I just get 7 minus 7 over x squared minus 6 over x cubed, right? So in this case, you see what's happening when I calculate the limits as x approaches infinity. I'll put a positive infinity here. Then what we get is the following. The numerator is getting close to positive infinity, and the denominator is getting close to 7. So as a result, we get positive infinity. You see, look, this is getting close to 0, 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 and this guy is getting close to positive infinity. Okay? And that's why we get positive infinity. Now, let me just change this problem up a little bit. Had we wondered what was happening if we were approaching negative infinity, in this case, then what would have happened is the following. The numerator, everything else would have been fine, but the only difference would have been right here in the 4 times x. That would have been approaching negative infinity, in which case this would approach negative infinity. So, okay, well, I hope this helps you out. Thanks.